When you look at the night sky, the light from a distant star began its journey billions of years ago, crossing a vast, silent void. For centuries, physics has modeled this light as a physical entity, a tiny, localized packet of energy traversing three-dimensional space until it impacts your retina. Richard Feynman's work in quantum electrodynamics complicates this trajectory. At the quantum level, a photon lacks a single defined path. It behaves as a probability amplitude, exploring all possible routes between the source and the destination simultaneously. If a photon has no mass and explores every route at once, the physical nature of its travel becomes difficult to identify. The observer-dependent theory of everything, or ODTOE, suggests a different mechanism. It holds that the photon never actually moves between the source and the receiver. The perceived flight across billions of light-years occurs as a chain of iterations. Each step reconstructs the state of the universe, shifting excitation from the source directly to the retina through a sequence of configurations. This diagram illustrates the two layers of reality within the theory. We experience the top layer, a structured spatial grid called configuration space. Below it lies potential state space, an underlying reality where the concept of physical distance is undefined. Discrete energy states emerge vertically from the unmanifested space, appearing sequentially across the spatial grid. These sequential actualizations create what the theory calls the actualization front, the boundary where potential states render into the world we observe. Motion appears to the observer as a continuous flow. In this framework, that flow is the visible edge of reality rendering itself into existence frame by frame. Since its establishment in the early 20th century, the speed of light, roughly 300,000 kilometers per second, has stood as the unbreakable limit of physical motion. ODTO derives this limit from the geometry of the phi torus, the foundational shape of the universe's self-observation loop. The relationship between its major and minor radii is fixed by the golden ratio. The speed of light, c, emerges as the ratio of the geometry's elementary spatial scale, r0, to its temporal scale, tau0. This geometric refresh rate remains constant across all recursion levels. The limit c represents the maximum speed at which the actualization front can render a new configuration. Quantum entanglement involves correlations that appear to ignore spatial separation. Measuring the spin of one particle instantaneously determines the state of its distant partner, regardless of the physical gap between them. Within potential state space, these particles exist as a single object. The separation we perceive is a result of that single object being projected into two different locations on the spatial grid. Quantum teleportation works by modifying the projection instructions for this underlying object. The object simply renders in a new location without traversing the space in between. Because these particles share a single identity in the underlying space, the correlations between them remain intact regardless of distance. These results suggest that spatial separation is a property of the projection process rather than an absolute barrier to connection. If reality renders sequentially, bypassing the speed of light would require a method of accessing the rendering process itself. Standard observation relies on a narrow operator window, limiting the observer to perceiving one configuration at a time. This creates the experience of linear time and sequential motion. High-coherence quantum systems minimize the stochastic noise of observation. As this noise clears, the operator window expands, allowing simultaneous access to multiple configurations. This mechanism provides a framework for N.A. Kozyrev's observations, where high-coherence detectors recorded a star's past, present, and future positions at once. An expanded window provides direct access to the unmanifested space where all configurations coexist. This allows an observer to perceive spatially remote states without traversing the intermediate steps usually required by the speed of light. These principles suggest that starlight is the live, continuous rendering of the cosmos. To look at the night sky is to participate in the instantaneous manifestation of the entire universe in the now.